All right. So I think we are settled and we can now start this Stockholm third event. So first of all, thank you for joining. We really appreciate people coming over finally in person. So really delighted to see some audience finally. And thanks also for the people joining remotely. We're gonna quickly introduce myself and my co-host Frederick, and then we're going to jump into the event-driven architecture with Kafka and Async API. So that's the topic of today. First presenter will be Andrea, and then the second presenter will be Matheus from Mulesoft. Thanks also to Mulesoft for having helped to organize this very good event. Okay, I think we can start. So
yes, thanks, Andrea. This is my slide. So welcome everybody to the Red Pill Impro Stockholm office. For those of you who are on site here in Stockholm, and for those of you who are joining remotely, also feel very welcome, of course. My name is Fredrik Svensson. I'm a co-host of this event, these Mulesoft meetups in Stockholm, together with Andrea. Myself, I work as a CBDO, meaning I work with business development basically at Red Pill Impro. I am also one of the co-founders of the company, so I've been here for a while. When it comes to Mulesoft and our journey related to Mulesoft, we at Red Pill Impro have been working with Mulesoft for many years now. Next year it will be 10 years. We started a partnership with Mulesoft back in 2013. And we have a lot of various customers that we have been working with here in Sweden. You can see a few names on them mentioned at the bottom of this slide. Red Pill Impro as a company is a fast-growing organization. We are currently just about 240 employees, and last year we had a revenue of about 550 million Swedish crowns, which is close to 55 million euros. We work apart from API and integration. We also work with the solution areas of DevOps, cloud, data analytics, and customer experience, where we also sales partners. So very welcome everybody, and I'm looking forward to the presentations from Andrea and Matheus.
Okay, thank you, Frederick. I'm going to quickly present Florence Next. And firstly, myself, I'm Andrea Martinello, CEO co-founder of Florence Next. We've been partner for kind of a long time as well, and I have a background in technical. I've been working with Mulesoft as a developer at the beginning, and then architect, and all the way to lead architect and practice manager. We are Salesforce and Mulesoft partner. We have offices mostly in Italy, but also here in Stockholm. And we are very strong on the public sector, private sector, like retail, fashion, automotive, especially fashion, since we are Italian, right?
Of course, it's in your blood,
Andrea. Okay, so without losing other time on this, I think we can move to our first presenter, Andrea Canale. You can reach on the stage and you can do it. All right.
Okay. So first, let me introduce myself. I am Andrea Canale, and I am a senior integration developer from Florence Next. So today we will talk about the event-driven architecture with Kafka and what we have used it and how we have used it. So to start, what is an event-driven architecture? From the definition, it is a software architecture paradigm that promotes the production, detection, and consumption of and reaction to events. What is an event? Events are something that happens in our system, or generally speaking, everywhere in any point of time. So as an example, we can take a customer that buys a product, a flight that is late, or a sensor read from an IoT device. These events are then pushed or detected by some components in the architecture that reacts to them with some kind of action. In our example, for example, the read of an IoT device can be consumed by a support service that creates a case to the support team. Or otherwise, in the case of flight late, a notification service can send to the customer an email. So, but why we are talking about this? Nowadays, all the applications are working with real-time data and they're providing a real-time experience, and they're using increasing and different kind of data sources. In this context, the capabilities on ADA architecture give us the possibility to scale and adapt to these changes, and it's also quite fast. And it is also quite resilient because it gives us the possibility to don't lose events and also to replay them if some failures occur during the processing. Also, we have to notice that when we adopt event-driven architecture, we found out that there is also a lower running cost in a cloud environment, because in contrast to a polling approach, we can save time that we pay in cloud computing. We save time instead of requesting data over the time. We saw that for the 90% of the time, we just request data without doing nothing. In a event-driven architecture, we just react and do the action. And which are the tools that enable us to create this kind of architecture? They vary from the well-known message broker technologies like ActiveMQ, RabbitMQ, or also AnyPointMQ, to the one more recent and more interesting like Apache Kafka. We can also integrate this kind of component in a classical API-led. In this example, I take the order management in e-commerce, where in the case of the update and insert also of an order, we can use these components in order to have a reliability pattern between the layers, so we can replay events. We can go also a faster response to the end user by just the experience layer. Instead, in the other case, when we want just to get the, oops, I'm sorry, I switched the two slides. When we want just to get the status of the order, we can use the classical REST API approach of an API model. So to move to the next topic, I just want to make a question. How many of you know Kafka? Just one? Just two. So, good. To give you a historical overview, Kafka is an open source stream processing software platform. It was first developed by LinkedIn and then donated to the Apache Software Foundation. It is all written in Java and Scala. To let people understand what we are talking about, I will explain how it works from the basis. So the events that I was talking before in Kafka is called a Kafka message that is composed by an header, a key, a value, and a timestamp. These events can be produced by the producer or can be consumed by the consumer. To remember that consumer in Kafka are consumer group. All these events then are stored in topics in a durable way in topics, and each topic is divided in partition. This partition can be placed also in different Kafka instances in a cluster. The important stuff here is that all the events with the same key are written to the same partition, where Kafka guarantees the ordering. This gives us the flexibility, tweaking the number of partition and the consumer in a consumer group to reach an exact throughput. Another stuff to remember is that in how the consumer are balanced in a consumer group. They are automatically balanced by Kafka to share a fair load between the partition of a topic. With Mulesoft, we can interact with a Kafka broker with a connector for the Mule for runtime that let us use all the basic operation and other ones like the publish and consume. And just a little tips that we found out about how to configure a consumer. You can specify two options that are mutually exclusive. That is the topic subscription pattern and the assignment. That, as I said before, one is automatically balanced, the other one is not automatically balanced. So, for example, in the topic subscription pattern, if we set the number of parallel consumers to 2, and we subscribe to a topic with just one partition, only one consumer will start to consume the event. The second one will consume only when the first fails. So then, to move to the next topic, there is the demo. I just want to say something that we believe that bringing a real case scenario is what the Meetup is made of, is intended for. And what can help the Mulesoft community is to share the challenge that we faced and also the solution. So to introduce the scenario, we were in a client environment where there were a set of Mulesoft microservices in a Cloud Hub environment, and with the API manager enabled, that were connected to an external identity provider that in this case was Keycloak. Then the client started an API product initiative in order to let his consumer his customers consume these APIs, but all the security related stuff were not handled by the portal. So at first we had detected, in order to enable the security layer of API manager to the application exposed by API portal, to use to propagate two events: the client application creation and the request access, in order to be integrated with the API manager and the Keycloak IDP. The first approach that we use is the CDC, that is the change data capture, that is a process that identifies, tracks the change in the database, that in near real time or also real times, and that this process stores these changes to data warehouse or queues. In our case, we use the Bisium implementation of this change data capture, that upon the action made on the customer portal, it takes the changes and publishes it onto the Kafka broker. At this point, we had a very big issue, because every time an action was done on the portal, different related events on the database were created and then pushed to the topics. We were in a situation that we could not recreate the original event that was meaningful for our integration. We came up with the solution was to adopt the Kafka Stream library, that is a simple and lightweight Java client library that provides stateful and stateless operation like merge and joins on topics. And we found out that it was really visible and embeddable in the new runtime with the use of the Spring module. This changed our architecture with the new merging service that was in charge just to merge these related events in something that can be reusable by, in this case, of this integration, but also, if we want also to, as an example, we can think on a creation on a new event, we can create a new case on Jira. That's so I will move to the use case. I've prepared some video, and just for some limitation of the client environment, all the demo was running on my local PC. So some events were also simplified to have a better overview. Let's start the video. Okay. So to connect to the first use case, we are creating a client application on the customer portal. And for the sake of presentation, I've also developed some custom API that simulates all the events of the custom portal in a local instance of the database, in a local instance of a Postgres database. As you can see from the left, I'm creating a client application with the name mobile app client application. As you can see to the right, a lot of events happened in the Mule application. As I said, it's quite fast. And then, okay, let's correct rules. And then we will see also the events that were created in the in the database. On the top, we have the application, in the application table, the application entities. And in the second table, the credentials that are attached to the first. Moving to the Kafka broker, this is a console in order to see the events. We see how the merged events are created. You can see the ID is 51 in this case, and the name is as before. And we can see how the client application is propagated to Exchange. The ID is 51. And also, and in this case, now I will copy the client ID in order to search better in the identity provider console. And here we can see how the client application is created also on the IDP. For the second, also, in order to have a better overview of the events that were happening in the new runtime, I connected the application to a NEG instance on the cloud. This is use cases. We will. Here we can see the custom portal that has created the application, the part made by the Java classes of the joining services, and the part that is propagating the client application to Exchange and to the external IP. In this local environment, it took 2.5 seconds to propagate the app to Exchange and less than 1 second to the identity provider. For the second use case, we are in a request access. So after a manual workflow in the client environment, an admin approved the access request from the developer portal, and a contract is created also in Exchange. Let's see. So here we start from a situation where on the table is already existing a contract that is not yet approved. and by the use of the custom API that I developed, I'm patching that contract with approved true. And as usual, we will see. Sorry, I got it. That's something I cannot, as usual, in the runtime. We will see how the entities updated on the DB, and contextually on any point exchange, the contract is created. Also, in this case, there were a support Elk dashboard. Here they are seems strange, but it started the join started before I can log the end of the patch of the contract. So we can see from the Kafka stream how it's trying to join different events from the application, client application entities and the service application entities. And then how we started to create the contract on Exchange. That's all I think I need time. Yeah. So, okay. Thank you for attention.
Thank you. So let me just see. Do you guys have any question for Andrea on this? Both remote people, if you can maybe type it in the chat, or if local people. Since no question. Okay. Online, do we have any question? All right. Okay. Then I think, thank you, Andrea. We can move forward to our next presenter. So I'm gonna interrupt the sharing here and hand over to Matheus, which now is a presenter. Matheus, can you hear us?
Yes, I can. Can you hear me?
Yes, we can. Hello and welcome.
Thank you. So let me prepare my share my screen and see if do you see it?
Yep.
Let me put this in presentation mode.
Yes.
Still there, right?
Yes.
Okay. So if it's okay, I'm good to go.
Yeah, please.
Okay. So thanks, Andrea, and good afternoon, good morning. Well, this is yeah, good morning still. So good morning, everybody. My name is Matheus Hermsdorff. I'm the first guy in the picture on the left. I am a solutions engineer here at Mulesoft, and together on site, I hopefully have my two colleagues, Nassim and Johan. Are you guys there?
We are, yeah.
Yeah, they're here.
Okay.
A bit in the background.
Good. All right, good. And so thank you minutes to actually present our ideas about event APIs and what we plan to do in roadmap. So I'll be talking about it in the next 20 minutes, and after that we can open for some questions. And as you know, Nassim and Johan are there on site, and might be easy for the people who are not remote to engage with those two gentlemen. But you know, without further delays, let's get to the most important, let's say, picture of the day. This is the picture of a mule, and some of you might believe it's a donkey, but it's actually a mule. And if you remember anything from the presentation, or for the coming 20 minutes, please remember this picture. That's the most important picture from the slide, okay? And perhaps also what it represents. What it represents is what Mulesoft does, which is similar to what we used to help people do the heavy lift. That was the originally goal for Mulesoft when it started, and it continues to be the original goal of Mulesoft now, and also in the context of event-driven architecture, right? Before we go into the content, it's important that you understand and read the entire slides that you have now. And if you manage to understand all of it, the rest will be easier. But if you cannot read, or if you don't have the mood or the patience to read all of it, I can summary for you, and it's very easy. And basically what it says is that a lot of the things that we'll be talking here is a product roadmap. And that means that this will be implemented, but we don't really know if something will change and when they will change and what are the happens the product roadmap. So that there we have a plan to do all of the stuff that we'll be talking to, but we know that there are different priorities that comes along the way that might change the plan. So if you ever make a decision to actually do something with Mulesoft, please use general available software that is available today. But if you're good to go, we start to get into the content. And as you heard from Andrea, Mulesoft is able to do event-driven architecture today. Mulesoft, in fact, has been able to do event-driven architecture for a long time, even before things like Kafka became a popular message broker, or even before architecture paradigms like API-led connectivity as approach came to really become popular within the Mulesoft ecosystems. So event-driven architecture is possible to implement with Mulesoft today, was possible for a long time. And we try to explain what we're going to be doing better to support event-driven architecture on the concept of a Mule life cycle, a Mule application life cycle. And some of you might have seen this picture before, or perhaps a variation of this picture, but it's commonly used when you actually build a Mule application in a form of an API. When you expose a REST-based API, where you have a design and you do a design first, and then you bring to Anypoint Studio and implement that. So this is the life cycle of a typical Mule application. And we're going to explain again, like I mentioned, what we plan to do to better support event-driven architecture on the context of this life cycle. Event-based integration is possible today, but could be better. And what could be better? We believe there are a few things that could be much better than it's now. It starts with how we model events. So if you look at the life cycle, the design part of the life cycle, the design first approach, where you have the design, prototype, validate, and the feedback loop with mocking services, that's where you first craft your API. And we believe the events can be crafted in the same way as REST-based APIs. So what we plan to do, and actually this is already done, by the way, is that we're going to be able to, we're able to model events within the Anypoint platform. And after you model those events, you should be able to start to build the publication side or the subscription side of the two sides of the event-driven architecture. And here comes questions like, how can I actually consume events? How can I actually do the data mapping and use data sense within my Anypoint Studio by capture the payload, the content of the events? Or how do I actually configure my broker? Do I actually have to know all the details of the broker, the specifics of the Kafka, the MQTT, the Anypoint MQ, the RabbitMQ, or whatever broker we have in place? Or can this be facilitated for a configuration point of view? And how do we test those events? Can I do unit tests, for instance, and introduce any units in that? But going further in the life cycle, what if I could actually, from the Anypoint platform, from the control plane, what if I could have visibility and manageability of the brokers itself. What if from the endpoint platform, I could manage the broker from the endpoint MQ, which is available today, but also for Kafka or for other brokers available out there. And could I even try to apply the idea of policies and the quality of services, those events, where I will actually configure who has access and what we can do in terms of quality of service for each one of those channels and those topics that are available on the brokers. And going further, to close the life cycle, what I can make easy for the developers of my organization to discover, request access to channels and to see the payload of a particular event. What if that could be placed in a library? So this we're going to be talking further on and how we're going to support each one of those capabilities. So the first one, it's something called Async API. So Async API is not something that Mulesoft invent. Async API already exists and is a modeling language to describe events, right? So open source initiatives that allows you to work easily with events, just like we do with REST-based APIs, and enable really the formalization of how you document events and how you generate code after that. So think that is really like the similar thing that we do with Swagger, we did with Swagger with Open API specification or with Bremo. So that's a formal description of what an API look like. And Async API is the same thing for events, right? And it's also protocol agnostic, right? We don't actually go into the details about how we're going to implement that, but what it is. And it's the entry point to allow us to discover APIs and to properly manage events within our platform, within Endpoint Exchange. Okay. So again, this is not an initiative from Mulesoft. There's many people out there behind, and it's something that you can just Google and check what it is. All right. So the first improvement, which is actually available now, if any of you log into the Endpoint platform, is that within the Design Center, what you can do is to log into the Endpoint platform, the Design Center, and instead of specify a new OAS specification for REST API, you can select the Async API. And then you're going to open Design Center. We can specify your events, your schemas, your channels, your servers, and you can put your different published channels or your subscribed channels. And that's something that is available today, right? You can just log in and it's there now. Okay. And because of that, we can also facilitate a proper documentation. So we can actually publish the specifications that you do in the API Design Center into Exchange. So people can actually search for that and see, hey, what is my payload of this event looks like? What if I want to go into the case quality? What does it look like? What is the example of that? What are the specifications of that? So this is something that is available today and you can check it now. Okay, and because it's available now, you can also have some degree of reusability today in Exchange, because you can actually search those events just like you search REST APIs. You can go to the Exchange and see a particular event type from event API, and you can actually search those components in there. And then you can see the associated metadata that you have on the right side of the picture. Going further in the life cycle, after you design a particular event and you do the design first approach, right? Also for events, you model those events, you have the event API publishing Exchange. What most of the time I do like to do is to go further in the life cycle. And that's something that is not there. Then it's points to, and you can start to implement that event. Use this sources of the published to actually start draw that event, the publish event or the publication event. Okay, and the idea here is that you have to leverage all that the student provides today with data science and so on. What you're going to see in the next couple of slides. So what if I could actually just palette the modules of Anypoint Studio and see that there is a predefined event, for instance, called case update notification. And that particular event, you can subscribe to the different events. So if you want to drag and drop, you don't actually need to actually re-implement everything from a Kafka to define the payload time, the method, so on, but you can just drag. Pretty much like we do this today for something that we call the REST connector. A REST connector is a product type, a REST API that you put in Exchange, that when you drag into Studio, it fills in all the information for you. So that's the first thing that we still have to do, but we'll be doing. The second thing is that, okay, the implementation now begins, right? So you can actually, like I said, choose if you want to subscribe to a particular event or publish. So if you want to subscribe to the event, of course, it becomes the flow source. And if you publish event, and that becomes a destination in the middle of your Anypoint Studio. And there you can actually see all the different bindings for the configuration. You bring you pre-configure information about what connectors you should use for that event. In this particular case, you have the AMQP, but it could be a Kafka, it could be an Anypoint MQ, it could be an Active MQ. And that configuration is also always stored within Anypoint Exchange. So the developer actually doesn't have to know all the details. And more than that, what it makes easy is that you could leverage the capability of data sense to actually see what is the payload of my message. So instead of actually have to explicitly import the metadata, this information will be captured from the design of the event of the API, which you once created in Anypoint Design Center. So here you see that you can actually just see the payload of a particular case update, and you see that we have a particular ID, is deleted, name, type, and then you can actually do the transforming of the message just like you would do with a normal REST connector. And all of this will be automated. Okay? And because we're gonna automate all of this like a REST API, you would also have things like the instances of a particular API where you can see that, hey, within my API manager, I could see that I have multiple instances of a particular API. The same concept will be for the broker, where some of those instances will be a production environment, a stage environment, development environment, and they will have different URLs to point to the respective broker. So this stuff is all pre-configured. Further in the life cycle, what you actually have is the idea of operating this this event-driven architecture, which means that yes, we're going to be able to manage those brokers, but we should also be able to monitor events, monitor the queues, monitor all the topics that we have in there. So the idea of monitoring the events that go through the platform will also be something that will be worked on. So things like Anypoint monitoring will be a bit richer than what it is now to capture information regarding the events. So that's pretty much what we plan to do on the roadmap. And to recap what we have spoke before about what we actually have today and what we actually need to implement tomorrow, you're going to see in this picture. So anything related to the design of Async API is available today. So today you can model your events. You can go into Anypoint Studio, you can go into Anypoint Design Center, and there you can model your event APIs. However, you're not able yet to consume those events from Anypoint Studio. Right? You're not be able to do the mapping, you're not able to configure the broker, the bindings configuration, and do any unit tests. You're not able to yet to manage the brokers and to even apply policies and quality of service information for each broker. But as you saw on the pictures, on the photos that I showed you before, you're able to actually go into the Exchange and discover those events. So let's say the first part of the life cycle, which is associated with the design first and the design of Async APIs within the Anypoint platform, the idea of publishing those elements, those assets into Anypoint Exchange, this is in there. And everything that you see in red, that's what we still work on, and they will be in the future, okay? And to summary, I would like to show you a bit of a diagram of what is it like before and after Event API. So like I said, we could always do event-driven architecture with Mulesoft. But before, we really have to do almost like a point-to-point event integration where a developer would actually have to know a lot about the underlying infrastructure. The developer would actually know which broker you're actually operating, if it's a Kafka, if it's an Anypoint MQ, if it's an active MQ. You'd have to know the details on how to configure that particular connector with the respective bindings, with the credentials, with the different queue names and the address and so on. You also would need to know the details of the payload of that particular event, what that event eventually carries, how to search the data mods of that particular event. And obviously you have to know the logic, what you do in your publication, the subscription side. But everything was, let's say, really almost like hard coding the connectors, right? Obviously, we can use the Mule properties to abstract that, but you actually have to know, and it requires a lot of knowledge from the underlying infrastructure from the broker, and again, knowing side of the metadata of the events and so on. And what we aim to do with Event API within the Anypoint platform is to lift up a little bit and abstract a lot of that logic, where the Anypoint platform, we actually, you're able to configure a particular broker in the Anypoint platform, and that configuration will be abstracted from the developers. So when you go into Anypoint Studio, you can drag and drop a particular event, and then we carry along all the configurations regarding related to the respective infrastructure of that event. And not only the infrastructure information, but also the schemas, the data model that the event carries. Okay. Have said that, that's pretty much what I would like to share with you in this short session. But if it's possible, we can open up for questions either for me or for my colleagues who are on site there in Stockholm. Thank you.
Thank you, Matheus. Thank you for sharing this. Very interesting to see also how is the roadmap of future development in Mule. So thank you very much.
Okay.
And questions? Any questions?
The obvious one is when.
I can adjust that one. So what we're looking at is to kind of during next year.
Next year.
Yes.
That's like 23.
23.
Oh. Wait for it.
Pontus?
Yeah, so my question is it possible in Design Center to model an API that has both Async API and more REST capabilities within the same API, or is it either or situation today?
Yeah, the second. So the nature of the APIs, the nature of the implementation of the APIs will be different. So you're gonna be modeling two different APIs. Eventually, if you decide to implement that within the same Mule application, that's the implementation choice that you could do later, and it has pros and cons. But now it's two different assets within Design Center, and also two different assets on Anypoint Exchange.
Yeah, okay. Because I was more in the kind of thinking more about the opposite. Like for the consumer, it would be perhaps good to have them documented on the same page, but then I want to implement them in two different applications. But yeah, that's cool. Another related question. I know it's not possible, but is there any work being done to share common data types between Async APIs and RAML-based APIs?
No, that's already possible.
It is? Okay.
Yeah, that's possible, right? So when you model a particular Async API in Design Center, you can, and perhaps you should, absolutely reuse some of the data types and the doc types that you have on the design center, right? The fragments of the APIs, you can and should reuse them.
Yeah, so you can import the RAML defined fragments in Async.
Yeah. Yes.
Okay. And yes, also I think in Andrea's presentation before we were showing that also the same asset could have 2 trigger points. One can be a queue. Of course, it needs a common data model in between what is operating on. No, at the same time, have an HTTP listener that can be triggering in real time.
The same application. But
the same application.
I'm looking at the kind of the exchange view of it.
Oh yeah.
If I'm a consumer that goes into Exchange and I want to see a complete API, I would actually have to look
2
at
assets.
two assets.
Yeah.
Even though they're
even though they're the same. Yeah. Okay, and the remote people, do you guys have any question? If you can please type it in the chat. In case. No question, thank you. Grazie Giuseppe. And hello from Sweden. Okay, then I think we are done.
Let's wrap it up then, Andrea. Thanks to everybody that attended on site. Good to see you again, and thanks to everybody that attended online. Hope to see you soon again. We will come back, Andrea, you and I, with another invite for the 4th session.
For sure.
We'll meet up of Stockholm events.
Yes.
It will probably not be until after the summer, I think, but we will let you know, and hope to see you again then.
Hope this becomes a little bit of a active community where we can keep doing this and just, share ideas and things. So thanks again.
Thank you guys for having me remotely.
Thank you, Matheus. Have a good day. Ciao.
Bye-bye. Ciao.
Så